All right, I started working on the radio. I pulled this capacitor out, which I knew would be dead, and it made it dead. It's a 4 capacitors in one, so it's a 30 microfarad at 450 volts, a 10 microfarad at 450 volts, another 10 microfarads at 450 volts, and a 20 microfarads at 25 volts. And then the can is negative, so here's the negative, and then there's 4 positives off the 4 electrolytics. So I'm going to replace that with actually 3, because 2 of the capacitors are used together. So the 30 is used by itself, and then there's a 20. So they paralleled 2 10s to get a 20. And that's in the power supply. There's a capacitor, and an inductor, and a capacitor, which creates a pi network for the power supply filtering. So that's all the high voltage stuff. Before I spend too much money on this radio, though, I thought, well, let me test the tubes. Turn this on so it warms up. So I have this tube tester, and Electronics Measurements Corporation. Anyway, there's a ton of things like this. It's not a great tube tester. This is a model 215. It doesn't do the GM of the tube or whatever. It just kind of looks for shorts and opens, make sure it works and stuff. Anyway, this one tests good. This is like if you went to the grocery store, or, this is the kind of test that you would do. So I just tested a 6v6. So it tells you in the book, you have to have a book that tells you how to test, and you have to set all these things. So the 6v6 says D, filament voltages, 2 for the filament selection, 3, 4, and 5, you put these switches in the up position, and then you set this to 31, and then you turn it on, and it either says good or bad. So anyway, this one's good. I will continue. All right, so far they're testing okay. There's one anomaly here. I have one tube that the chassis is marked 6SK7, and the tube is marked SJ7. So I don't know if it's an upgrade or a substitute, but 6SK7. So let's look it up in the book here. 6SK7, it's a double tube, and the J7 at K7, they're about the same in the book here, so we'll go ahead and test it with a K, since that's what it's doing. 6SK7 is D, 2, 4, 6, and 8, and 31. The only difference is the J, you set the shunt to 33, so we can change that and see if it makes any difference or not. So this one's testing good, and I'll put up to 33, and it tests even better. So yeah, this one's fine. This one's a good tube. All right, one anomaly. I just wanted to film it so I have record of it. All right, so I have removed the front panel. So this is a big 1/8 of an inch piece of steel here. I think that's steel. Yeah. Anyway, that goes here. So I had to take all the knobs off, and the knobs are very strange. They are, let me show you here. See if I can zoom in here. I think you can. It's really hard for me to see whether this is in focus or not. But anyway, there are a bunch of knobs. So there was knobs everywhere, right? And these knobs here have a very strange set screw. They're not hex. And you look into them and they look like they might be Phillips. And I tried Phillips to begin with, but really the best thing to do is they're basically for a flat-headed screwdriver, but in 2 different positions. So I used a real small flathead, and that worked the best. It could fit in at 90 degrees to the 2 slots in the thing. And then you get all of that out of there, and you figure, okay, I'm ready to go. And then you get to the big ones here. There's a big one that goes here, and and there's a big one down here, and those actually have hex screws in them. So go figure. So the two big ones are hex, and everything else are those flat ones. So if you ever rip one of these apart, that's very strange. Very, very strange. I had to take the meter out also to get the front off. So why am I taking it apart? So I'm taking it apart because of the mechanism that controls these two things. There's a tuning capacitor here, and then there's a bandwidth here, and I need to figure out how those two things work, but I know they're broken. So there's two knobs on this shaft. There's a concentric shaft here, and when you turn one, it moves this one, and you turn the other one, it moves this one, and I could feel them just start to slip. So there's probably grease in there that's just gone dry and welded the two together. So this needs to all come apart. There's a great video online on the Radio Shop. What's the guy's YouTube channel? I watch him all the time. He repairs old radios. Anyway, he has a great video of this exact unit and taking this whole thing apart. So that's helped immensely. So my next step is to let me turn this thing around. Whoa. So my next step here. Are we in camera here? Yeah. Okay. This whole thing has to come out. This whole unit has to come out. So I need to take the two couplers off of these capacitor banks here, take these two couplers off, and then take a bunch of screws out, and this whole thing should come out. And then I need to disassemble this whole thing and take that shaft out and clean it and everything. In the Radio Shop video, he claims that he would have liked to have remade a few of the parts if he had a lathe and a mill. Well, I've got a lathe and a mill, so I'll see how bad mine are, so I might rebuild them, but I need to see that. There are some bulbs here that just clip on, so I'll need to pull those off. There's 3 bulbs. There's a bulb here, and there's a bulb down here, and there's a bulb here that goes into the meter. There's a missing light bulb here, so I have to find a replacement. These are probably 6.3 volts. Probably runs off the filament voltage of all the tubes. Anyway, that's where I've gotten today. Took quite a while to get all this stuff off. Anyway, my next step is to disassemble that thing. All right, it's out of the radio. So this is the mechanism, and it looks more impressive from the bottom. There's lots of stuff going on here. So I don't want to damage the dials, but there's two concentric shafts, and let's see here if I can. That might be a little bit too far. So there's this mechanism here that is a clutch, and it either grabs this ring here and stops it, or it grabs this ring here and stops it. So one is turning or the other is turning, and right now it's just not working right. So I think what I'm going to do is try to pull this big shaft out of here and clean it. Like I said, I think the 2 shafts are just got gunky goo in them. So yeah, let me get to it here. All right. So I got the back part off here. There's a wheel that goes here that engages this, and then the clutch grabs that wheel, and then there's a bushing and a little wavy washer that holds that all together. And then I was able to, once I got that off, I was able to loosen this shaft. So this shaft went all the way through. So this is the thing that sticks out in the front. and then the clutch mechanism goes through that. So when you turn the knob on the clutch mechanism, it flips that thing around that engages the clutch, or it disengages the clutch, wide, narrow kind of thing. And then this is the band spread, and then this is the main tuning is on the outside. So anyway, it's all apart now, and so I'm confident now I can fix it. I don't think I'll have to disassemble it any further than that. I really don't want to. I think I can just kind of clean it up from here, put some brake cleaner on it and get it going. Brake cleaner is just acetone, so it's just acetone in a can. I think it's got a couple other things in it, but basically acetone in a can. And there is a little collar here that goes on this shaft. Interesting. And there's a groove. And there's a groove here. Looks like there's some washers here. I don't know. Yeah, these are loose. Yeah, these are loose. So, oh, I see. So there's a split here, there's a groove here, there's a split washer that goes on that, holds that in. Then there are two washers here, and this all fits on it together. So this all needs to be cleaned up. And there's gunk. I can feel the gunk on this shaft here. It's just dried grease. And we'll get it all going and put it back together, hopefully. Anyway, yeah, let me clean it up. Okay, all back together, and it seems to work. So let me show you how that clutch works. So I've got the little knob on the end here. So you can see the clutch goes here. So now the clutch is squeezing here, and it's not allowing this cog to rotate, but it is allowing this one to rotate. So when we rotate the outer shaft, this shaft does not rotate. And if we go to the next setting, and then this shaft is locked, it won't move. But the inner shaft now lets this one move. So looks good to me. So I could put it back on the radio.